Welcome soil conservation and management students at the Royal University of Agriculture to our session 15 video lecture series. This is video lecture 5. We're going to talk about yield monitoring and mapping. In fact, let's go ahead and just add mapping to that. And I am Dr. Jared Williams from Brigham Young University, Idaho, and I am a visiting professor at the Royal University of Agriculture here in Phnom Penh, Cambodia. We have been talking about different applications of GPS, GNSS, depending on where you're from, and GIS in agriculture. In some of our previous lectures, we talked about zone and grid soil sampling, variable rate technology, site-specific crop scouting. In this video lecture, we want to talk about yield monitoring and mapping. Let's begin by defining what yield monitoring and mapping are. Yield monitoring is using data or using instruments on the grain combine or harvester to collect yield data as the combine or harvester moves across or through the field. In order to monitor yield, we don't need a GPS, but in order to be able to create maps, we will need a GPS so that we know where we are in the field. Some common crops that we use yield monitoring and mapping in are things like grains, rice, wheat, corn, pulses, mung bean, soybean, cotton, and peanuts. In order to monitor yield and record and map, let's write that on there, yield, monitor, and map, these are the components that we need on our harvester. We need something that will monitor how much weight or how much material is coming through. This is called a mass flow sensor, and it measures weight. So how many kilograms of material? Next, we need to know the moisture, because if the grain is wet, it will weigh more than if it's dry. And so by knowing moisture, we can then adjust the weight according to the moisture. If we want to map, we also need to know where we are in the field. This requires a GPS or GNS, a Global Navigation Satellite System, or in the United States, what we call a Global Positioning System, or GPS. We also will need a computer to record the data and monitor the data, as well as a device to record the data on. The key components, though, to monitoring or capturing yield data and being able to map it is the GPS, the yield monitor or the mass flow sensor for measuring weight, and the moisture sensor so we can adjust that weight based on the moisture of the grain. Let's talk a little bit about the yield monitor and how it, or display, I should say, the display. Here is a picture of a display showing the combine moving through the field. This area here is the area already harvested by the combine or harvester. It will continue to record that data as it moves through the field. It has what we call a field boundary going around the field. So it knows the total area of the field. Oops. So it knows the total area of the field. It can then, by knowing the total area that it's harvested and the total area of the field, it then can calculate a yield. This information is in U.S. units, bushels per acre, rather than kilograms per hectare. There is the moisture. In this sense, they're harvesting corn at 17.9% moisture. It shows the total amount of area that has been harvested by the combine or harvester, and the total wet weight. That weight is different, notice, it will be different by the dry weight. Again, remember we have a moisture sensor on the combine so that we can adjust that weight based on the amount of moisture. This yield monitor, and or I should say the display, this yield monitor display happens to be the same one I have in my combine at the BYU farm. The neat thing about this is that it records the yield and creates the map on the go while the combine is harvesting the field. It also gives you the yield average, and it can give you the yield for each location as you move through the field. At the end, you can export that data and create a yield report that includes a yield map. This yield map shows topography along with the yield. You can see here areas that are red were low yielding and areas that were green were high yielding. A lot of the area on the sloped locations was low yielding. This information could be very helpful in identifying areas of the field that may need better management, specifically soil management. The yield report provides not only the map, but provides other helpful information such as the average yield on the field. It also includes the coverage area, how much area was harvested. Again, these are in US units, so it says 90 acres. That would be approximately 40 hectares. The season, as well as other helpful information. This information can definitely be used to improve our soil management and improve and reduce soil degradation. For example, yield monitor and mapping helps farmers to identify areas in the field that have low yielding or high production areas. These areas then can be further examined to see if we could modify our inputs. Other information that can be used from our yield is tillage. What areas of the field may need different types of tillage? Residual removal. Is there enough residual material in the field that we can remove it and use it for feeding animals or bedding for animals, or bedding or feed for animals, or for bioenergy? Therefore, we avoid removing residue when there isn't sufficient there. We can also, based off of the low and high production areas, identify if we need to change our fertilizer recommendation. Maybe we need to add more fertilizer to our low areas to increase production, and our high production areas may require less fertilizer, but they also may require more fertilizer. We also can assess our irrigation requirement. Maybe the low yielding areas may not have had sufficient irrigation, or may have had too much water. Also, we can use that data to assess crop rotation. If yields are continuing to decline, maybe we need to change our crop rotation practices. Again, helping us to improve our conservation agriculture practices. All of these, removal of residue, crop rotation, irrigation, can help us better manage soil erosion. Fertilizer recommendations can help us reduce non-point pollution and improve our productivity. This concludes this portion of our video lectures on yield monitoring mapping. These slides also contain a review of what we talked about in session 15 and some questions that you can answer to ensure you understand the content in session 15. This concludes session 15 video lecture number 5.